So with trusses, they come in all different shapes and forms. So the first thing you've got to realise is when you actually see a truss like this one, is not to become intimidated by it. It all works the same way. It doesn't matter if it's this way or if it's standing on its head. It does not matter. The truss is the same thing as the bridge truss. However, like with a bridge truss where this would be on the ground, if we had this as a space diagram, we would see that this would be attached to a wall. Okay, so this sort of thing, what we're looking at, it's attached to a wall. So if you can imagine, here's the wall, and then there's some lights on the end of the wall, and that's what this truss would be holding up. If it was upside down, again, you'd find that the truss would be something like a bungee cord thing, like where you're actually jumping off it and it's being held by the roof that way. Okay, so again, it's the same thing. What I'm trying to get at is don't be intimidated. It's the same thing. Whatever we're doing here, like for moments, it is force by distance. Okay, force by distance. It doesn't matter where it actually is. Okay, so we don't want to get fooled by that. So when looking at this analysis of these members, the first thing we need to do is find out equilibrium. It's as easy as that. Like we've got to work it out what forces are actually in play here, holding it to the wall, because that's going to come into play there as well. And that'd be the way that I'd actually start with that. Start with something that you know. Sum of all moments equals for this one. So you're taking the moments around here to discover this force, and then you're actually going to just sum of all forces to work out what's happening at the pin joint. Okay, same as we've done if it was just a beam bridge. Now the other thing with this here, and I'm just pulling this apart to try and see what I actually know. I know that I'm going to be actually trying to analyse some of these triangles. Okay, so I've got this triangle, which is a little bit different from these ones. So this angle will equal this angle will equal this one, this one, this one, this one. Okay, so I definitely want to find out what this angle is. And this one here is going to give me a little bit of trouble, so I want to find out what that angle is for some of the early calculations that I'm doing. Okay, so there's my first first three steps: sum of moments, sum of forces. Find out what these angles are, and they're all the same, so I only need to find out one, and then find out what this angle here as well. Right? Once I've done that, then I can start chipping away at doing the members. Okay, so let's have a look and see how we actually go with that. Right. Now, the other thing that I've actually put in here as well, like I've started this list, just like of my knows and needs to knows. So the knows, I've got the drawing and they've given that to me, so that's what I already know. And all I've done is started this list, so it's going to help me understand what I need to do. For example, I need to find the horizontal force in the bottom roller. I need to find the horizontal and vertical in the top, right, in this pin joint. I'm then going to find out the angle of EAF, which is that one, and then I'm going to find out the angle of FEA, which is that one, okay? The question actually asks for, if I come back here, find the force in each member by analysing the trusses below. Okay, so I've given myself a list of trusses. Trust me on this. Trust me on this. The whole idea, you really need to keep stock, because if you don't, you'll get lost. So by doing this little list here, right, I've actually got a situation where I know all the ones that I have to do. I can now see the work that has to be done. It gets less confusing. Now, at this point, if I can just stop. You won't get this question in a HSC exam. It is far too big. However, the process being used here, once you master it, your method of sections gets a lot easier. So at the moment, we're doing methods of joints where we're analysing each of these joints. But the process here, once you learn it, the next step gets easier. And that's why I'm getting you to go through all of these. Okay, so sum of all moments at the bottom. Now, like I've labeled, like they've got labels A, B, C, D, E, F, which is great. Just so I don't get confused, I'm calling this one here force bottom horizontal, and that's why I've got FBH. So this is going to be force top horizontal and then force top vertical, just so I know where I'm at, okay? So again, moments around the pin, and I come out at 186, okay? So force by distance, and I'll get that down here. Same deal with the pin, excuse me. I've actually got the sum of all forces. So at the moment, if I come back to my diagram, the only horizontal forces I've got is this one, which is pushing that truss out so it doesn't fall. And I've got this one here. And when you think about it, it wouldn't be pushing it out, because if it's pushing it out, the whole thing would be falling off. So this one's actually opposite. Okay, so it's holding it to the wall, where this one is pushing it out from the wall. Okay, so again, sit back, think about how is this supposed to work. It's attached to a wall. This is definitely pushing it out. What does this one do? Well, if that's pushing it, it's got to hold on to the wall. Okay, so I'm doing that analysis as I'm going. Right, so sum of all forces horizontal, sum of all forces vertical, and then our journey has actually started in calculating this out. Like I said, the next thing that we want to do is find these angles, and you can see here, tan angle is opposite over adjacent. Now, where did I get these from? Like 1 and 3? All right, let's come back to our drawing. We can see that between the pin and the roller, it's actually 3 meters. Okay, it's a 3 meter distance. We can see between B and A, it's a 2 meter distance, and this is half of that distance. So that would make that 1 meter, and that's 3 meters. And now I can start doing my calculations that way. Okay. So coming down, pulled that apart, got 18.4, pulled that apart and got 71.6. Now again, I've come back and I've just redrawn this as my free body diagram, so I know what I'm looking at. Again, it's all coming back to getting it straight in my mind. What am I doing? Okay, so I've got my forces here, I've got my forces here, I put in my angles. So now you can see it's coming down to a situation where I'm calculating the members in the triangle, so it's basic trig, and then adding or subtracting external forces if need be. Okay? Look, you guys have known me over time now, and you know that my mind is a 1980s mindset for mathematics. I've really got to get it down pat so I understand everything. I know you guys have got shortcuts. You actually whiz through the calculator a lot better than that I can. So what I try to do is get my head sorted. This is the way that I do things. If you can do it another way, like see the sense that I'm actually doing, and you can do it another way, go for it. But please, please, please understand that to get full marks, you need to show working out and a correct answer. Okay, so say if you want 4 marks, working out and a correct answer. If you show the working out and get something wrong, you can still get 3 out of 4. Okay, so it's really important that you show the working. If you just give a correct answer, you're probably going to be sitting on about 2. You can't get full marks without showing the working out. Okay, so just be aware of it. Now, one thing that we've actually got to do here, like with this, and this is part of my brain mindset, I've got to work out whether these members are in tension or compression. Okay, let's keep this in mind. We're analysing the joints. Okay, so here, if this is a joint and it's in tension, the member itself is in compression. Okay, so it's pulling back on itself to form that tension, and vice versa. If the joint is in compression, then the member is in tension. Okay, this will become a little bit, look, I get confused by it. That's why I draw it down all the time. But if you get your head around it, your life gets easier, but it is important for the actual calculations in the drawings itself. The other thing I get confused with is, and I'm not confused, but it takes time. So like in some of these cases, and I'll show you the first working out, rather than break this down each time, I can use a schema like this. If you haven't seen this before, if I actually want to find out what sine is, I cover sine, and I know that it's sine angle equals opposite over hypotenuse. If I want to find out the opposite, I cover that, and I can see it's sine angle multiplied by hypotenuse. I want to find out the hypotenuse, I've actually just got sine, opposite divided by sine. Again, we do this in our head, but like I said, it gets a little bit confusing. By having some form of schema like this, life just gets a little bit easier. And that's why I put it down and I draw it all the time. Okay, so recapping before we move forward. I've got moments around the pin to find out this force. Sum of all forces to work out what this force is. I've worked out my angles, so now I'm going to start pulling apart this truss to work out what's happening in each of these members. Right, again, my list, my unknown member list now. I've got that down. I've got the other part solved. So the first thing I'm going to do in this case here is look at joint F. Okay, joint F is actually quite simple. It's got a force going to the right. It's got a force going up, and that's what's acting on that pin. Now, in that case, then I've got two other forces that I need to find, which applies to my rule in doing a method of joints. Only working with two unknowns, okay? Two unknown forces. That's what I'm working with, so I can do that. So I'm going to come back down here. Sorry, I'm jumping around. Okay, so here in my drawing, I see if I can just make that a little bit. Oh, no, it doesn't want to go bigger. Okay. I filled in my 186.7 kilonewtons pulling to the right, 180 kilonewtons going directly up. And now we know for equilibrium, for this to be an equilibrium, this force needs to equal this force needs to equal this force. So there you go. Quite straightforward. And I can now tick off two of my members. Okay, you can see here, like, bingo, it's getting a little bit simple, and I'm looking at that. So the next thing I've got to do, I've actually got to come back to this and go, well, what's the next easiest joint to look at? And I'm going to say here probably A. Okay, I've got this force now, I've got this force here, and my two unknowns will be EA and AB. Okay, and they're the ones that I'm going to work on and find out. My free body diagrams in this case are specifically around the joint. Okay, I want to stay focused on the joint. So I've gotten rid of all of the rest of the junk around it, so I don't need to worry about that. I'm just worrying about this joint. I filled in my unknowns. Right? Now, if you remember, and this is where it gets a little bit confusing and you need to get your head around it, this force here is pulling away from the joint. Okay, pulling away from the joint, putting tension, which means it's in compression. When I come down here, this member is still the same, so it's still pulling away from that joint. Okay, the member's in compression. It doesn't change. The member's in compression. So this one here, I know, is pulling away from the joint. Here I've got my 186, and from the original drawing I've got, it's pushing onto the joint. Okay, so now I've got these two that I can actually understand. I now need to think about what's happening in the other members. For AB, it's quite simple. I've got this pushing that way, so AB has to push back on that joint for equilibrium. Okay, it has to be pushing back for equilibrium. I've got this joint pulling up, so AE has to be pushing down to try and get some equilibrium in there, in that actual truss. Okay, so take your time and make sure you analyse this and get it right, because it does help. Now that I know what I'm doing, I can actually work this out. I'm looking at this one here, and I can see if this was a full triangle, here I've got an angle and I have an adjacent, so I'm now working with cos. Cos 18.4 will equal adjacent over 180, and the math just works out that way. Again here, if it's pushing onto the joint, I know then that the member needs to be pulling back to keep it in equilibrium, so it's actually in tension. Okay? The joint's being compressed, so the member is in tension. Again, same deal, another force triangle, right? I've now got this. I know that this one here is 71.6 because of my other calculations, so I can now start to work that out. Oh, I've done a drawing again. Free body drawing to show you what I'm talking about. Okay, so I've filled in what I actually now know. And I'm starting to calculate this out. AB is what I want to find. Okay? To find the horizontal section of this force, right, I want adjacent over my hypotenuse. AF has no horizontal force, so I'm just going to ignore that. And then this one here, I've got the force going in the other direction, which means I'm going to have to subtract it. So again, the sum of all forces, AB, right, it's positive AB plus positive AE plus or minus 0, doesn't matter what you say there. And this is minus 186.7, and just work the calculation. Okay. Again, I'm coming back and I'm filling in the work here as I actually go. Again, this is my mindset. It just saves the confusion of flicking backwards and forwards, and I know what I'm actually doing. So you can see what I've done so far, and like I've gone through and I've done the rest of it for you here. But what I'd like you to actually do is see if you can just work the triangles and find out what these members are before looking at the answers below. If you can get your head around this, the next step, which is method of sections, gets really, really easy. But it's a process and you need to follow it. Work through it, see if you can actually solve the rest of these members, and again, go back and have a look at the steps that I've taken to make sure that you've got it through your head how the process actually works.